Support comes from the Missouri Forest Products Association, committed to conservation and careful management of the state's forests to make them more resilient and better habitats for wildlife. ChooseWood.com.
From St. Louis Public Radio. This is St. Louis on the Air.
Is it maybe a better thing to be flexible, though? I mean, we hear so much about climate change. Our world is changing so rapidly. If you're a species that can go up and down, are you maybe more ready for whatever comes?
Exactly. That's the next frontier of biology in this key innovation study system. If you are constrained to live in a certain environment, what are the dangers of doing so? Well, if you have these toepads and you have rapid climate change, for whatever reason, it could be dangerous to only be able to live in trees.
I'm Sarah Fensky. Aryeh Miller studies lizards. He's a graduate student in the evolution, ecology, and population biology program at Washington University. And he spent the last 6 years examining these reptiles, including a close look at those sticky toe pads that give them especially good grip. His work looking at the evolutionary aspects of these adhesive toes recently paid off with a study published in Systematic Biology. And he joins us today to tell us what he learned. So Aryeh Miller, welcome.
Hey, Sarah, thanks so much for having me on today.
So I got to ask, what first got you into lizards? Aryeh, are you still there?
Sorry. Yep, say that one more time.
What first got you into lizards?
That's a great question. Thanks so much. So lizards are intrinsically really an excellent group for any eager biologist of any specialty because they're distributed across a wide variety of habitats across a planet. So what I mean by that is you can go out to the middle of the Pacific Ocean and find lizards that specialize in diving into salt water. Or you could go to the middle of the Saharan Desert and find lizards that are great at burrowing in the sand to evade those hot summer suns. So on top of that, we found that lizards over 6,000 species worldwide. That is, we can go anywhere on the globe and find several species in pretty much any given habitat. So we can answer a wide variety of questions in evolution and ecology given this.
So were you really coming in that strategically? This wasn't like, a 4-year-old kid falls in love with lizards. You were thinking, okay, this is really an excellent subject for study.
Definitely. So it wasn't quite aimed like that. Well, my co-author James Stroud and I, we both have this great interest in lizard biology, but also one of these big questions in evolutionary biology. That is, what is the role of biological innovation in explaining patterns in the diversity of life? So we refer to this question as key innovation theory.
So that's a really important theory for this study. Tell us how toe pads fit into that.
Yeah, definitely. So adhesive toe pads are these microscopic hair-like outgrowths on the bottom side of these toes on hundreds of lizard species, but only 3 major groups. That is lizards, that is geckos, skinks, and anoles. Now, if you take a look at one of these lizards and use a very powerful microscope and zoomed in, you would see a forest of micrometer-wide hairs that allow lizards to adhere to virtually any surface. And this is facilitated by these complex frictional interactions. So they're using these interactions with the ground and also these interactions between molecules, which we call van der Waals forces.
And so this gives them, you've called this a biological superpower. What can they do with these sort of sticky pads?
That's a great question. So we typically compare these toepads to lizards that live in trees that have long, sharp claws. Now, when you have long, sharp claws, it's really hard to cling on to these slippery branches and leaves. Now, we've noticed over decades of studies that lizards with toepads can cling on to these slippery leaves really well, which really gives them this biological superpower to live in areas where lizards that have these long, sharp claws simply cannot.
And you've said that these 3 major species that have these toepads, that they evolved them independently. How do we know that?
That's a great question, exactly. So we call this convergent evolution. That's when 2 species evolve similar features owing to similar environments or just a similar spectrum of natural selection. Now, it's actually more than 3 species, so it's 3 groups. That's skinks, anoles, and geckos. Now, this amounts to hundreds of species across the globe. Now, this makes us a really powerful environment for testing these different questions in ecology and evolution because we have these independent trials of evolution. So it's kind of like we bottle up evolution and we see what happens each time when we give these lizards toe pads.
So these toe pads for these lizards, do we know what happens first? Whether they get the sticky toe pads and then they climb up the tree, or they're hanging out in the trees and then they evolve the sticky toe pads?
That's a great question. So that's actually one of the major paradigms of our study, which is understanding, do these key traits evolve adaptively? Well, what we find out is that when over millions of years, lizards climb up and they start to live in trees, we actually find out that these toepads evolve adaptively. That is, they get into trees and then they evolve the toepads, as opposed to evolving them on the ground or in some other habitat and then going up into trees and living up there.
So they're up there in these trees. A bunch of them end up getting these nice sticky toe pads. What happens to the ones who are up there and don't make that evolution?
Exactly. So, like I said, there's these lizards that live in the arboreal environment, that is, in the canopy or higher up on the trunk of trees, that have other adaptations to living in trees besides these sticky toe pads. So they'll have these long, sharp, curved claws, which allows them to dig into the trunks of trees. So it's kind of quarreling when you go into a forest. You could go into a forest in northern Vietnam, or you could go into the forest of the Peruvian Amazon and see all these different arboreal lizards, some of which have these long, sharp claws, and some of which have these toe pads. So we're trying to understand, well, do these lizards have an evolutionary advantage which have pads?
And so, drum roll, what is the answer?
Well, we found out that they actually do, but it matters how you define it. Well, classically speaking, biologists have been interested in answering this question using species richness. That is, comparing two groups of lizards, one of which has some number of species, and the other group has another number of species. Now, this is one way folks have done it, but James and I are interested in kind of doing it in a different way. That is, how can we kind of synthesize the dynamics of evolution and ecology more integratively? So what we found was that we can build these models that estimate, well, what is the rate of transition between one group of lizards that has pads and lives in an arboreal environment to a state of living on the ground and not having toe pads. And what we find is that lizards that live in trees and have toe pads will rarely transition to arboreality, that is, staying in the trees and maintaining a state of toe pad loss. So that is, if you have toe pads and you live in a tree, you are not going to lose those toe pads.
What about the other lizards, the ones that don't have the toe pads?
Exactly. So it turns out if you do not have toe pads, for example, if you have those long, sharp claws, and you're up in the trees, you will transition to life on the ground at a far higher rate than a lizard that has toe pads.
And so that life on the ground, is that a bad thing potentially for their success?
We're not so sure about that exactly. So there's nothing wrong with living under the tree, whether you have claws or toe pads, and there's nothing wrong with living on the ground. But part of the story is kind of, well, what is a key innovation, and what does a key innovation imply for the evolution of an organism? Now, one of the central things of our study is, well, what does a key innovation imply for the organism? What we find is that a key innovation makes a lineage committed to a certain way of life. That is, if you have toe pads, you are very likely to be in that tree and stay there for millions and millions of years, as opposed to where if you have claws, you will go down and up over a period of millions of years. So you're much more labile in your distribution of ecologies over evolutionary time.
Is it maybe a better thing to be flexible, though? I mean, we hear so much about climate change, and our world is changing so rapidly. If you're a species that can go up and down, are you maybe more ready for whatever comes?
Exactly. That's the next frontier of biology in this key innovation study system. If you are constrained to live in a certain environment, what are the dangers of doing so? Well, if you have these toe pads and you have rapid climate change, for whatever reason, it could be dangerous to only be able to live in trees. Whereas these lizards that have more lability in their ability to go in between trees and the ground, they might have an advantage and be able to adapt at a higher rate than these lizards that are committed to life in the trees. So this is very interesting for studying climate change and extinction biology.
So this biological superpower over time could end up being something that holds them back. It sounds like that's the thing we just don't know yet.
You bet. Folks have been studying this in fish, actually, in Central West Africa, but we have not yet studied this in lizards, and it's certainly a next frontier of something that we're interested in understanding.
And is that something you personally could end up involved in, or are you more laying this research out and someone else is now going to run with it?
James and I have both mainly been interested in kind of forming this modeling framework for folks to take their own study group and run with it and see what they can find with it. This idea of climate change and how it impacts key innovations, we're still learning more about this every day. We're not so sure about it, so we're looking to dig into it a little bit more, but I'm definitely hoping to look into it a bit in the future.
It's interesting with this model that you've built here and what you're able to show from it. We might think of biologists as you're all out in trees and individually measuring, things and examining people to see who has toe pads. That's not really how this work worked. You had a database that you were able to access that researchers have been using for years. Can you tell us just a little bit about that?
You bet. So a few years ago, a fellow in Israel by the name of Shai Marie collated this massive database of the natural history and ecology of lizards. So what he did was pervade the literature and basically tried to understand, well, what is the ecology of all these lizards? So you might take in a lizard from the Solomon Islands, for saying, you say, well, this lizard lives in trees. Add it to a row on the Excel database. So we did this for over 6,000 species. And now what the community that studies lizards has, a giant database of lizard natural history and ecology. Now, all these observations were gained by folks going out to these islands or going out to these different rainforests and understanding and observing what is the ecology of the species and then publishing those in small notes. Well, it's kind of hard to see how that scales, but over decades, we have this massive database now. So what James and I were able to do is take this large database and put it into this kind of cohesive evolutionary framework where we have all the different ecologies and morphologies for these animals, and then try to estimate these evolutionary dynamics over time.
So now that this database is so big and people like you and your research partner here can find things like this, do you think we're going to just start seeing bigger and bigger discoveries as people are putting things together?
I hope so. I certainly hope so. So we're now in this age of big data. And here we create this great example of, well, what can we do with this big data when it comes to these cohesive evolutionary analyses? And I hope that we can span this just beyond lizards, but there are these great databases of fish evolutionary trees and fish data and ant trees. So we can really expand to all sorts of taxa to understand all sorts of questions and hopefully provide all sorts of answers as well.
So I guess one small irony, though, of the databases, maybe the future of your field, is right now you are out in the actual field. You're in Puerto Rico. What are you doing there?
Yeah, I'm actually in Puerto Rico helping out in a postdoctoral fellow at Washington University, Dr. Kristen Winchell. And Kristen's interested in understanding something that I'm also interested in understanding, which is what is the basis of adaptation? Now, here in Puerto Rico, there are populations of lizards that live in urban habitats in Puerto Rico and forest habitats in Puerto Rico. Now, what Kristen and her colleagues have shown over the past few years is that lizards that live in urban habitats actually have adapted to these heat islands in urban habitats much better than these forest lizards have. So we're basically going out into these neighborhoods and these forests and measuring, well, what is the urban heat tolerance of these urban lizards, and what is the forest heat tolerance of these lizards that live on mountainsides? And what this can tell us as well, how are lizards adapting to climate change? What does this mean for the future? And how fast does rapid evolution proceed?
And do you see that maybe by looking at lizards in this way, we'll be able to understand the world in a way that even goes beyond lizards?
You bet. Kristen is providing a great basis for understanding adaptation in terms of understanding the genetic basis of adaptation, as well as the anatomy. What happens when you go out and catch a lizard in an urban environment, and you look at it and you measure it and compare it to a lizard that lives in the forest? These are all things that we can understand by getting your boots on the ground and looking and going out and catching lizards.
So it sounds like these databases are huge, but we've also got that close observation. We kind of need both in order to make these advances.
You bet. Yeah. So it's kind of scaling from these micro perspectives of looking at one species to all these macro evolution perspectives, looking at thousands of species across the tree of life, can provide us insight into all sorts of questions in ecology and evolution.
Well, Aryeh Miller, I want to thank you so much for joining us today and getting us up to speed on the latest with lizards.
Thanks so much for having me on, Sarah. Appreciate it.
St. Louis on the Air is a production of St. Louis Public Radio. Understanding starts here.
Do you find yourself regularly listening to episodes of St. Louis on the Air? Suggest us to a friend you think might enjoy our conversations, and leave us a review and rating on Apple Podcasts on the App Store. It's the simplest way to help people discover our show. Thank you.
St. Louis Public Radio is a member-supported service of the University of Missouri, St. Louis.
Support comes from Missouri Forest Products Association, committed to sustainable and sound conservation of the state's forests, which support more than 41,000 Missouri jobs, resulting in a $10 billion industry. ChooseWood.com.